The next speaker is Tomislav Krizan, who is Chief Product Officer at Atomic Intelligence. Tomislav is a big data practitioner, but also a project manager and leader, and the team leader, His talk is titled 1984, The Big Brother is Watching You and Helping You with Savings. So the floor is yours.
Hello? It's working. So should I start or should we wait for a few of them to leave us additionally? Okay. Title of my talk is 1984, Big Brother is Watching, and basically I'm talking about smart home and how to do smarter automation of those. And I took the title intentionally, the Orwell from the watching perspective and from all the sensoring you can have in home. So this will be our agenda. First of all, what kind of relevance I have to give you this kind of talk, because majority of us are data science and we need to establish some boundaries. Then we'll start to talk on one of the major driver recently in home automation and smart home, which is IoT, and later on Internet of Everything. We'll talk about what are intelligent building, what are the smart homes, and what do we really have on the market at the moment through the reality, and what issues do we have, like man in the middle, we'll talk a little bit later about it, and what we did to try to solve and basically create a really smart home solution. And if there is a time, we'll have a Q&A session or give Linz additional time to cover his topic. So, my relevance. Born in the 70s, so I went through different countries in the meantime and different political environments. So the blue lines, which I'm now talking, is relevance from IT perspective. Started with first computer interaction in 85, in 87 built first scanner, start doing the programming in 90s, first commercial software, start building touch-based solution for movie rental places. So in 97, this was done as a basically subscription model. So we didn't provide hardware boxes to sell somebody, we did the pure lease. And it was done with a lot of analytics in the background. Who are the players in the movies, what kind of the genres. You can do a lot of mix and match to see what you would like to choose in the movie or something like that. In 98, I did on the college automation of industry, overseeing automation of industry communication and sensoring. So that was IoT in 90s. So we did a lot of communication through pure modem networks. So those slow ones, we needed to transfer 1 million of events per second. That was really tricky how to make it run. So we did a few things where we draw the pictures on the back end and then send results just to show analytics on the front end without need to move millions and millions of events per second. And then later on I start to work in a data analytics spectrum. So late 90s, I stopped working in software development and hardware development and went into data-driven aspects. Working in consultancy, built that practice, and then in 2015 I decided let's go step back, let's start to look into different businesses which we can do, focused on AI, ML, etc., etc. So this blue line led us to 2018. Oh, we are missing part of the slides. Good to know. Led us to the large green circle as well, which is 2018. But at the same time, this following link is my electrical knowledge. In 84, I started and joined radio amateurs, where I saw that first PC and started working on them. Well, it wasn't PC, it was Orao and Galeb computers, which we had in ex-Yugoslavia, which you built by yourself to work. So you needed first to build computer to work on computer. So that is my access to that one. So when I started working with electronics, building different components, I built the first scanner for those computers. It has really good resolution, about 0.5 centimeters with 0.5 centimeters, so you can see what you could scan and show on those devices. In the 90s, built the first of many amplifiers for guitars, and then later on different effects for playing music, etc., etc. And then started doing hardware communicational interfaces for computers. What you can scan as an input device or output device from the computer world. And this led to that, again, 97, where we built a touch-based solution for movie rental places. And we leased it quite a lot until the renting of the movies become obsolete. Now Netflix is our worst enemy, so you can rent it over internet. And that led later on, home automation, first iteration I did with old X10 protocol, which is still one of the best protocols for any automation, because allow you to communicate with a bunch of different sensors at the same time, and you don't have a limitation which you have currently with a so-called smart solution you have at the moment on the market. Majority of the solutions at the moment you have on the market are working through the Wi-Fi connectivity, which has a limitation of 32 sensors per hub. So if you have need for more sensors, you'll need to invest more money for buying routers to connect all of them and start getting some information from it. So in 90s, this was really easy because you had parallel communication. Each will send your information. I'm sensor called A. My status is this. Please do something. All of them running in parallel, and you didn't have a limitation in connectivity. In 98, started with those PLC and industrial sensoring activities collection. So we built a collection, stream collection agent to build that streaming tool, which we then later on applied on industry. In 98, there was only 2 solutions on the market doing something like that. This. We and one other company for which you needed to download a lot of software from the internet to make it work. So smart home automation as a next phase in 2011, where I went into new direction. We started a new sensoring, etc., etc. Again, 2018, we started to apply AI on top of it to get some meaningful result. Besides that, a music career, start playing guitar. This is the reason why I needed an amplifier here, so that I can have band, etc., etc. One of the bands, so each of those is leading. So this is a complexity you can see. I will not talk about sport, etc., etc. So from scientific perspective, this is what am I. So born, did a little bit in 84, where I started with the radio matters, filtering, did some CNN convolution basically to see what I'm capable, and then classify that one. And I have 2 outputs. Am I capable or not? So for some things I am, for some things I may fake it, but let's see this a little bit later. Yeah, so just fake it, yeah. Recently there is a paper about fake science. So what is a home automation? There is a lot of talk about smart homes, and a lot of telco providers and insurance providers are providing you with some kind of smart home solutions. Reality check, they are not. So they are just automation, smart devices. They are not smart home, they are smart devices. So why this is a really huge industry and becoming huge industry? Because of 3 C's. You need convenience, that you can access, that you can control your environment, etc., etc. And you have cool factor. I have it, somebody else does not have it. So I can do everything through my phone, or I can talk with my house. And there is issue when it starts to talk back, especially if you don't have smart devices like Alexa or Google Home, and somebody is speaking, you need to visit doctor at that point. So IoT is helping you with this one. Helping because it's bringing a lot of additional information which you can start correlating to get some meaningful result. And this is one big picture of Internet of Everything. What can be connected? From the chairs, from the pluggable sockets to the weather controls, whatever. So everything can be connected at the moment. So one trivial question before we continue. Do you know what was the first IoT device? And a potentially year when it happened? So something...
1998?
No, 91. And it was a coffee machine. No, sorry. The coffee machine is 92. In 91, it was iron. For ironing, so Iron Man. So this is what is leading. So you have connected devices, unconnected devices, some of them which can communicate, some which can't communicate. You have even smart chairs at the moment who can rearrange themselves in a room when nobody's using them. So there is a lot of potential how to make you convenience at a home. So this is what is leading this large investment. We had IoT even previously, but now it's really affordable. So if you want to build any sensor or even buy sensors, now it's a matter of cents, not matter of tens of euros or hundreds of euros to buy some of those sensors. Well, some of the brands are still selling them in hundreds of euros, but if you start building it yourself or ordering through Alibaba or whatever, we are talking about cents. So in my home, I currently have few hundred different sensors, and for something like that, spend a small amount of money to connect everything and start integrating and getting information out. Okay, different segments where we can use IoT, but we'll focus on consumer part, home automation, and some smart objects which can be utilized. So what is, at the end, intelligent building? We talk about those devices, but this is one of the definitions. The building which can affect your lighting, heating, energy consumption, etc., and it can be remotely controlled. So interface is important. So different interface can be achieved. Voice, touch, gesture, all of them can be done here. Or from the other side, what is intelligent building? So house is one part, building is basically like a hive. What we can exchange between smaller buildings, which are, or smaller homes, which are part of the building, to get full environment. Fire protection. So one of the issues with the fire is when you can open and which doors, or where to direct people when you have fire hazard in those buildings. One of the largest issues, or largest problems for firefighting teams is also if people are opening doors which they shouldn't open during the fire, because new higher volume of oxygen coming into already place under the fire will erupt that one, and it will just scale massively those fires. So it can bring a lot of automation in this aspect as well. I need to lock those doors, I need to direct them with lights in different direction, shut down the lights somewhere else that people will not go in that direction, have smarter way to evacuate the building. So a lot of different approaches, what I can do and have intelligent building. At the same time, I would like to have all of those personal information which are on a home level, well, basically kept on that level and communicated on a smaller level which is not identify you as a person, so between the homes. Only communicate what you really need. One of the examples is also heating. If you are in a building, heating some of those flats in a building can affect everybody. So you have one person who is not putting heating on, which automatically affects how much heat loss will be in that building from other occupants, because they'll need to put more heat to stay on the same level of comfortable part to keep it in a house, and you are the large, well, basically you are the one who is losing heat for them. So you are draining their heat. So you are enlarging their bill cost or something like that. And at the end, you are making your whole building to be not so efficient from energy perspective. So that's something which is connective society as a next step. How can we all work to have a comfortable environment at the same time start saving? So those are comments what are intelligent building, but why really we need those? So one of them, how to deliver benefit beyond just energy efficiency. This is what everybody is talking about. They are talking about smart homes. It will be energy efficient. Your light will automatically go down when you leave the home. Your heating will go up or down when you are home, depending when you are, what kind of schedule do you have when you are at home, when you are not. So lowering the heat or pull it up, etc., etc. Those are what is currently done on the market, but it's just energy efficiency, and it's a smart thermal scheduler or something like that. But this is something which distinguishes all of them. All of those devices are connected to the cloud, and majority of them is prone to security attacks. So I'm not sure how many of you read, but there is a really good case about one of the industry which was had hackers through the Philips light bulb. So through the lighting, they hacked the company through the lights, and they stole the data. So that's an issue, cyber attack. Smart city is driving this kind of smarter homes. So all of those connectivity that we know, the traffic congestion, we listened, Mario, this morning, how they are talking about flow of the people. All of those can also, outside in environments, from the parking spaces, et cetera, all of them are contributing to information which can lead to intelligent buildings. So about parking spaces or whatever is needed. Again, intelligent building from occupants, they can optimize this to minimize, again, any kind of consumption. There is a famous case from Microsoft Redmond building. It's really a large building where you can have about 20,000 people. But about 10% of them show up on work. Everybody else go to the client location. So if each of those employees from Microsoft Redmond building need to be on their site, and they all have a reserved seat, and nobody is using it because 80% of them are somewhere else, you have large unnecessary expenditure on electric, on heating, et cetera. So what they did, they start to make it smart. When you come to work, it will assign you space. Okay, go there. So that's your new space, and everybody knows where to find it because automatically it will light up on a location. Where is your location? On a table, you'll see the name of not new, of an employee who is using that table. So you don't have your personal space. And they started to rent the rest of the building. So now they are making money from the people who are somewhere else. So they are not losing. So this is, again, how to optimize this part. Again, climate change is also the part which is driving this kind of smarter home, smarter city, and connected society. Green energy is also one aspect. I can generate energy, I can spend. How to balance those? So through different aspects. So I'll not talk, this is one of the slides which General Electric is doing, from the heat pumps, from the solar panels to thermal conversion. All of them are working together to make your environment comfortable from one side, that you keep level of comfort enough, and from the other side that you are saving or even earning money with your environment. But at the end we have reality. So reality check. This is also what Alex told previously. Currently on the market, it's all about Internet of Everything. All of those devices. It means that we need to connect all of those devices to get the data, to start accessing those data and then start applying some kind of analytics and provide unique value. The unique value is some future which we need to provide from those environments. This is what majority is already done. Getting the data, connecting to the cloud, and provide you with some analytics and provide you with some steps how to save. But it's not all. We need to go into the next step, how to correlate all of the information that we can have truly connected and smart home. And if you look from this perspective, majority started with this. Google bought them because they want to know when you are at home. Nest thermostat. Because then they know how to target you. One of the largest currency on the market at the moment are you, your behavior. So if they can sell your behavior to different market companies, this is how they are making money. So your behavior. Previously, there was one saying, if you know who am I, ask my bank. But now if you want to know who am I, ask Google. It has more information than the bank. It knows where you are going, what you are using, what kind of comfort and when you are at home, et cetera, et cetera. So it started with a smart thermostat, heating, lowering the consumption rate from the keeping a cooler environment when you are not at home, starting preheating when they know that you will come home, et cetera, et cetera. But it's still a relatively stupid device. What if you break your leg and stay home? So it needs to adapt. After that, it started with intelligent lighting, mood scenes, et cetera, smart appliances. So for all of you who have a Samsung phone, about 6-7 months ago, one of the latest release, if you open it, you'll see that you have a smart thing object. So your phone is connected to TV, it's connected to your fridge, if you have a Samsung fridge, it's connected to a washing machine, and I tried it at my home. So when the washing machine is done, you get a pop-up on TV. I'm done, okay? take all the out and put it to dry. No. So you need to walk around, etc., etc. So there is a lot of elements which are currently talking. But again, they are proprietary. So Samsung is talking with Samsung. You have a lot of different protocols on the market at the moment. And this is what's the real confusion is. What the smart home is. Nest is not a smart home. It's a just smart device which is connected, and it has a bunch of additional sensors to provide you with intelligent thermal or temperature schedule. It's nothing more. It's a just schedule when I will go up or down. It's not lighting. It's not switching your lights on, off, or whatever is needed. So for true intelligent home, you need to start collecting all of those information and need to start combining them to get a meaningful result. And this is what you are converting into something called smart objects. This is a typical architecture from the smart home. You have a bunch of devices which are connected to the gateway or a hub, and it's communicating with the cloud, and then you have some device where you are monitoring those information. Either your mobile or tablet somewhere at home, or you have Amazon Alexa or Echo or Google Home or whatever. Something which can convey you environment. One of the largest issues here is the data which you are generating are going outside. Somebody is using your data. Now, if you ask different people, half of them will tell you, I don't mind, because I have flexibility here, so do whatever you want. You have people who don't want to give you those information. Why? Because if you know my patterns, and if you have a person who can access my pattern and they don't have good intent, but rather bad intent, they know when I'm not at home. Somebody can come at that point. And from the other side, you have a bunch of different protocols for communication. That's an issue as well. So that's one of the issues from the communication, and this is the reason why, again, 50% of the people like cloud, because they are removing this issue from you. But if you are data scientists, you know that you like to play with the data, and one of the major pain in that work is preparing the data and accessing those. Well, initially when you go through that step, everything becomes easy. So when you get those data, you can do different things. So cloud-based approach, it has its own pros. Why should you approach it? Money saving, energy saving, convenience, customization. And unfortunately, we never have a European surveys or something like that on this on technology aspects, so we'll use US. We see that majority of those tasks which are currently generating smart home or smart device hype is adjust thermostat, okay? Change lighting to LED lighting, that we have smaller or greener footprint, and that we have lower energy prices or rate. Turn off light when I'm not at home. So there is a good joke when one old Scotsman was on his deathbed, and his wife is beside him, and he asks, "Wife, are you here?" "Yes, I'm here." "Is my first son here?" "Yes, he is here." "Is my second son here?" "Yes, he is here." "And why do we have our light switch on in the kitchen?" "Put it off." So, you know, the Scotsman in there saving. So that's also turn off, turn on, adjust appliances which are spending electricity when they are even switched off, like on standby. There is a large footprint which can be used here to save. But if you see here, all of those cases are just how can I save something, not how can I do something smarter with it. So this is why it's pushing into smart devices, not smart home at the moment. The major con here is that it's prone to hacker attack. All of those technologies or those protocols we saw are not secure. And if you want to go with a secure protocol, then we can't connect enough devices to have whatever we want in our environment. And the learning curve is always quite steep if you are using those kind of third-party solutions. So what we try to do it yourself. There are kits, but there are also for those who are prone to make their hands a little bit dirty to make some of the components by themselves and make it quite easy to start getting the results. So I need to put warning here, do not try this at home. Trained professionals have done this. You can get yourself injured, or even worse, your friends may start laughing you what you did. So, and I need to put the picture of a trained professionals as well. One of the first aspects is to go with a wired or wireless approach. Wireless approach in current aspect is by Wi-Fi, and it's limited. But if you go with different wireless approaches like RFIDs, 433 megahertz, like radio communication, etc., all of those are short range, which enforce that data will be private, local, and scalable. Or if you go with the wire approaches, that's also an option because majority of the sensoring you are using is just emitting the data. So what we did here, we piggybacked on the electricity you already have in your house. So we just created a network, well, you can also buy it, a network device which is converting a normal communication into your electricity. And the good part, it will work only in your home. It will not work outside because it's you have a transformator to go outside, which is immediately limiting your communication. So it's keeping it at local, keeping the all communication local, and you already have wiring through the walls, which saves a lot. You don't need to drill through the walls to connect those information. That's important. So how many of devices can I connect? And this leads to smart objects. Smart objects is basically an option that we convert those smart devices into objects which are talking together. One of the examples is phone. So if you go at your home, it's automatically registering to Wi-Fi, etc., etc. Use it as a trigger. Location detection, we know that this is when this person came at that flat, let's start adjusting thermostat, etc., etc. Or somebody's ringing the doorbell. What we can now do, and there is also a solution, when somebody's ringing, majority of the newer environments already have video on interphones, so you can see who is on the other side. Burglars are using this method to break in. They are starting to go from the home to the home and ringing, and if nobody is answering, they know that nobody is home. So one of the solutions is to piggyback on that as well. So take the video communication and send it over the internet as well. So you can answer on your phone and start talking like you are at home, well, on your phone and talk like you are at home with somebody and pretend, basically. You are at work, but you are answering your home doorbell. A lot of different appearance how you can communicate and start making them smart. And what we did on top of it, start to learn habits. Learn for home automation. This is what is making really home smart home. So till this point, everything is just a smart object which are doing some reactive component. But let's make it smarter, that it has some policy to react on either my behavior or some other influence and do some action on top of it. So what we started to apply is AI on top of it. Two different methods. We started, because what I did at home, I put also the small cameras inside of it together with the audio recording devices that we can track also patterns how people are going through the home. So you have those footprints, etc., etc. And you can learn just by audio who are the person who are at the home, even without the talking, because each person has individual walk. So if you have enough information, you can profile the people. Well, again, if somebody breaks a leg or something like that, it's making an issue with your environment. It's an outlier, yes, definitely. So break both of them so that they don't walk. Okay, so those systems need to be carefully analyzed to provide you something which is meaningful. So let's try to test it to get results. If results are not satisfying, let's do additionally. So do not be afraid to fail. And with those video devices, we started to use two different approaches. So with a Q-learning, which is a reinforced, to constantly learn how the people are behaving in the home, which helped us even with the broken legs. So, okay, my behavior changed now. Let's adapt. So we need to adapt to those information. And all of those is possible because each of you in your life, it's a set of activities or actions you are doing from the time when you are wakened till you go to sleep. So majority of us are doing one thing at a time. So some of them are able to do in parallel. So men can claim that they are doing things in parallel. That's only if they are female in the soul. But let's say that it's a sequence of events or activities which can be done during the day. So if we know that there is a sequence of events of occupants of the home, we can start modeling activity or reaction of home to our behavior. So over the period can be learned, can be adapted, especially because when we are talking about sensoring, all of the sensors are sending discrete values, either temperature or noise or moisture or whatever. All of those are discrete values which are semi-additive. We don't need median, or what we are interested in is in some thresholds. So are we up or below, etc., etc. So this means that we can start drawing sketches about our behavior, which are basically allowing us that we have online models which are constantly learning. So just adding on a previously learned experience. Okay? And to be able to do this, we needed to become that issue. The issue for all the home automation at the moment are hackers. We needed to become hacker of our own home, to cut that cord to cloud and start sniffing the traffic. So who has enough resources, it can deploy Metronome, which is a network sniffing tool built by Hortonworks and Teams, and it's already doing a lot of it, and it's generating all of those events you can capture on your device, because this is a router you already have at home, so you can capture all the information. Or if you are lazy, you can buy dongles from Alibaba or whatever, which is already intercepting and doing this instead of you. So getting those information. The good part is as soon as you get information, you can send it somewhere, either to persist it, like physically store it and then I'll do analysis later, or you put small message queue for stream processing. And this is what we did. Through the stream processing, we started to analyze. And we said a majority of those sensoring are discrete values. So especially if I'm tracking is my light on or off, etc., through the sensors, not through the switch, I don't need every 10-second record that I know that my light's on. I need to know when it's on and when it's off. And was it live in the meantime? So start filtering, start looking data in the sliding window, because sliding window helps us in a streaming environment to adapt to any change. So this is what we do in any machine learning or data mining project to try to minimize effects of any seasonality. So when we have the sliding window, we don't have seasonality issues. So we are constantly looking on a smaller scale. And again, try to push anything you don't need. In our case, why should I have a sample every 10 seconds? Because I can simulate and during the analysis all of those samples if nothing changed. So we start to learn here. Again, 3-step approach. Generate all of those data, capture the data, and then we start processing to make decision. And we found that there is a lot of stupid decisions. Let's, delete that models. Let's start with the new ones. And then do automation and online learning to fix it always, so that we don't need to build model daily or weekly or hourly or whatever. Let's build something which is constantly learning. Well, we have some level of confidence how accurate it is, but it's working. It's already know when it needs to switch lights on, where to switch it, etc., etc. So it's learning, and every day it's learning more and more. And for this, we went with the old approach, DIQW, which said, let's try to access the data and what kind of information we can extract from the data. Let's try to see what kind of knowledge or what kind of instruction those data should apply to understand it. Why should we do this? Because this is basically that we did something really good previously. And then convert this into wisdom, or how should we predict the future? How should we react to some either outside environmental event or based on our previous knowledge. So this is with the Q learning, with reinforced, etc., what we did. It's constantly learning and adapting. So we have reward. So reward or penalty. So if you completely missed my action, we penalize those models, and then let's start learning a little bit differently. So this is the reason, because all the knowledge is the synthesis of multiple different sources at specific time. So how to react? So let's do a little bit nicer picture to show you how this looks in a home situation. We have different information, like part of the day and how the time is changing. We have blinds. We have a switch on and off. And we have when somebody switched the lamp on and off, so lighting, etc., etc. We learned, and we can apply automation to elements on a lamp and on our blinds, because this is something which can help us in automation. And as I already said, interaction is something which is key here. Majority of you already saw that for home automation, bunch of people are using Amazon Alexa, Google Home, etc., etc., which is really wrong. We introduced something called single point of failure here. And recently, 2, 3, 4 weeks ago, there was one viral video starting to spread around about a guy who completely automated his home through the voice, and he went on a dentist appointment. And they pulled his wisdom tooth, and he came back, and he couldn't talk. And the rain started to fall, and he couldn't go into his home. So this is an introduction of a single point of failure. So you need to have multiple different ways to communicate with your home. Voice, good, because it's relieving, it's easy. Touch, through the different interface. But even gesture. This is something I'm playing recently. I told you that I have cameras. I put some cameras on some places in the living room, etc., etc. Why? Because this is also maybe not for our region, but maybe for somebody who is richer. When you have a burglar or even somebody come to kidnap you, you can draw the gesture and trigger the silent alarm just by doing some random move. And nobody will know what you did. I did like this, and it flushed my toilet, okay? Cool. So some of use cases which we start to play around, those basic use cases where you do on a single element. You start to control light, TV, radio, you control your blinds and sunscreens, all of those, one-to-one. It's relatively easy. And then we started to mix those. Let's see what we can do here. Wake up comfortably. So this is a really good feature which you get when you start learning of your behavior and have access to different kind of sensor or devices which can do something in your home, like blinds, lights, etc., etc. Majority of you will basically create your alarm. Let's say that you want to wake up at 7:15 or something like that. And first thing, when it starts ringing, you'll hit the snooze button. So give me 5 minutes. 10 minutes, etc., until you are late, and then you need to run. So few snoozes. It's proven that if you are applying wake up comfortably, and I'll describe this one, that first of all, you will wake up really rest, and you will not have need to lay down additionally. So you'll start your day even fresher. What this means, that your environment will start with waking process 15 to 20 minutes before you need to wake up based on your behavior, because each person has different span. It will start slowly dimming lights or making them more brighter, putting some music to pull you from the sleep in wake condition. And you definitely will not need a snooze button, because it will gradually bring you. And it's proven, and from a medical perspective and from psychological as well. Pretend you are home. If you learn your behavior, how am I walking when I'm switching lights on and off? When I go somewhere else, my home can do the same for me. And pretend that I'm home to be a false alarm. So that those who are looking at my home, they will think that somebody is there. Not randomly. At the moment that you have environments which are randomly switching something. But if you have my behavior, what I do on Monday, Tuesday, Thursday, etc., etc., and it's behaving every time the same. How much am I opening the windows, etc., etc.? All of those things. It prevents. So this is, again, prevention. Security and prevention. Energy saving, that's the standard. Controlling in-house elements. Auto-locking and unlocking through the devices when you go to the home. So this is you already have with the car. When you are close to the car, it will automatically unlock. Sometimes it's not so smart, but it does it. You can switch it on or off. Some of correlation. You start using equipment to predict when equipment itself will malfunction through different correlation of information. Fire and safety, I already talked about that environment. I'll skip this one. correlation between different sensoring. Audio versus other to correlate, did something really happen? There is a lot of sensors on the market which are doing a pitch detection. So did your glass break or something like that? Did somebody break? And then what you can start correlating with a temperature sensor, with even airflow sensor to see, do you have real breakage due to the intrusion of burglary, or it's just so large temperature differences between inside and outside which led to breakage of the glass, and what kind of breakage, etc., etc. Or eliminate false positive. I need to elaborate this one through multi-verification. I told you that a lot of smart devices are currently marketed through insurances, through telcos, etc., etc. One insurance in France, well, they offer to their clients to install some devices, and if they install those devices at home, they'll minimize the insurance rate. And those devices were to prevent fires or detect fires, not to prevent, sorry, to detect the fires, etc., etc. And they had a really good marketing activity, and one part of the town completely accepted that activity, and all of them put all those sensors. What happened about a week after is that every hour or something like that, fire sensors start to switch on, and constantly firefighters start to come into that part of the town, and nothing happened. So what happened in this case? They had birds who are chirping the same way like the sensor is expecting, and they are activating fire alarms. Birds. So no fire, just birds singing. So that's the false positive here. So you need to have multi-verification. So this is the reason why never trust a single source of truth, whatever it is. Verify it. In a health case, telehealth, like connecting citizens, so your devices with the environment, especially for older citizens, when they to detect falls. This is really issue with the older citizens. When they fell down, and it can be hours until somebody comes home and find them laying down on the ground. They are not able to stand up. So you can detect and you can react on top of it. A reminder when they need to do something, etc., etc. One of the cases which I implemented, it's a mold detection, which is really interesting, especially when you buy a new flat, but majority of the walls are already full of damp because they created the building and they needed water to make the walls, etc., etc. It's full of the water, and you can detect this easily. But even better, you can prevent this even easier, because prevention of the mold is it's just change on your behavior, heating and cooling and extracting the moisture. Combination of your heating and combination of AC or those cooling devices which extracts moisture. So those two together will prevent you a lot of troubles. And then a scary case as the last one. Well, luckily it's not scary for us yet. It's scary for English-speaking countries. Through audio communication, detection of depression. So this is something recently discussed and described in a paper by Stanford, is how your type of the talk can lead to detecting of depression even without knowing the context. Why are we talking about this? There are a few things how you can detect it, but again, the leading part here is that you would like to prevent, and prevention is always better. So if somebody is have tendency to go into depression state, depression can be altered through different outside environment, through the music, through friends, etc., etc. So do I need to alert somebody to come and talk with him, or do I need just to put him a soothing music or something like that? So last year I talked about people profiling. This is also the on top of it, how you can, when you profile the people, how to react on those persons. So prevention is the key. And to conclude, there is no place like connected home. So I would also like to say, that's all, folks. So I'm not on social media. If somebody wants to follow me to see what we are doing and how, this is how I look from behind. So just follow me and we'll take a drink or two. If you have any question, I'm here. Thank you. Oh? No questions? Okay.
So questions? If
Dreams.
there's no questions, that's all, folks.
Thank you.
Like with the capital.
Yeah,
T.
that's all. Thank you.